review something. Okay, what are they? In case you don't understand those maths, the pronunciation about those notation. Okay. Okay. Addition, subtraction, multiplication, and division. Okay, so if you use them as a verb, this is plus, or you can say and this is a verb, this is minus, and in a positive way of the positive, this is a negative, and this is times, and you can say multiplied by. Okay, we will repeat this again and again in my class. So I need to make sure. Divided by, and this is equal, is okay, greater than, less than. Okay? Square. Cubic. To the 10th power. This is to the power 3, to the power 4, to the power 5, to the power, okay? Okay? Okay, moreover, x plus 1. How to pronounce this sentence, x plus 1? This is x minus 1. This is minus x, or negative x. There are 3 pronunciations about this one, xy. You can just say xy, x times y, x multiplied by y. They are all the same. X over y, x divided by y, x over y. I will use this very often. X over y. Okay? X over y. And we already introduced this. And for this one, square root. The square root of x, the cube root of x. This is the nth root of x. Okay? Okay? And the last one, and then there are one more. Okay. For this one, a minus something, and this is the sum. Sum means b plus c. Okay? So this is a minus the sum b plus c. Okay, this is one thing. Or a minus, this is not a sum, this is a difference, b minus c. Okay? For the next one, this is not a sum, not a difference, or we will call this quantity. This is minus b minus c. So a minus quantity minus b minus c. Okay? And for this one, this is the fraction. This, I call this fraction. The fraction x squared over a plus y. Okay? Okay. Yeah. And this is the calculus. We have the differential calculus and the integral calculus. Okay, differential, integral. And we also have the partial derivative. Partial. Okay. And we have this one. No, this is the function. Function f of x. The function f of x. F of x. Okay. F prime, we introduced this a couple minutes ago. And this is F prime also, but this is f of x, right? So you can say this one. This is the first derivative of f with respect to x. Because it's 2x, partial 2x. Okay. If you don't use it very often, you don't remember. When you never use it, you don't know, but it's not a big deal. The first derivative of x, of f, with respect to x. Or you just say f prime x, that's it. It's an easy way. And for this one, the partial of f with respect to x, partial. Okay, this is partial. Alright? How to pronounce. That's it. That's it. That's all I prepared for the rest of the class, and you know what I'm talking about. If you don't know, it's your responsibility. You should know. Okay? So, here is the most important thing I want to introduce you to understand the 4 Maxwell's equations. You can come in, don't worry. You want to listen? Just sit in class, it's fine. Okay. We are talking about the spatial vector. You can just come vector up. It's fine, don't worry. The vector operators, what we are going to do for the Maxwell equations, then you can answer your quiz, okay? Okay, so you know, here comes the question. Do you know the difference between the scalar and the vector? Any of you? Maybe, okay, next, do you know the difference between vector and scalar? Can you give me an example?
The vector have the sign above the letter.
Oh, that's a notation, but why do we need a vector and why do we need what do we need a vector?
The vector is for searching for the direction.
Yes, direction. The most important thing is the direction. Okay, I try to introduce why they are different. Yes. Please say loud. What is this? Yes, and then this is. Okay, they are different. Okay, can you hear? Scalar and vector. Okay. When we learn the x, if you have a function, you try to present the relationship between x and the y, which y equals to the f of x. It is a function of x. If you have a relationship like y equals to x, it's a line, right? You know this one is very simple, clearly. This is, we call this input. And this is output. Okay? This is the answer we want to know. And this is the question I give you. For the same rule, probably if your rule is x squared, so this function will become, right? So I give you different x, and you give me different y. This is the relationship between y and x. Those are all, this is the input and this is the answer output. This is a question. I give you this one, and then you give me the function, and you give me the answer. Okay? Okay, this is for the scalar. It's pretty much, this is a scalar, this is a scalar, x squared is scalar. So, when we talk about a vector, something different in the EM field, what is different? If we discuss only the EM field on a plane, the plane is x and y plane. They are both the position where it is. X and the y, they are both input. This is different about what we are talking about, the scalar. The y is the equation of f of x, but this is different. In the vector, sometimes, this is one of the example, an easy example. This is xy plane. Both x and y, they are input. If I put a charge here, if there is a current charge, what happens? Do you know this one? If there is a current charge here, this is the position of this current charge is not moved. It's not moving. It's staying here. So if you put another current charge here, you will have a force to push this charge away, right? Do you know that? If this one doesn't move, you put a current charge here, you will something to push this away. This charge will go this direction. If you put the charge here, you'll go this direction. If you put a charge here, will put a direction, right? This is the first thing we can observe. Then second, you will realize that if your charge is close to this original charge, this maybe change the color, the black one. This is the original one. When this charge is close to this one, the force is getting larger and larger and larger. Okay? Okay. So, we want to describe this situation. You put the charge in different position, but you will suffer the force to different other position. And the magnitude, how big the force is different. This is a wave. This is an E field, electric field. Because you need to describe everything here, you need a vector. Okay. So, you need to describe what the field is, you need an equation, a simple equation to describe it. And then this equation is the function for both x and y. They are not the output. Y is not output. This is also an input. You tell you where you are in the y direction. Tell you where it is to the distance to this axis. This is the definition of x and the definition of y. So xy is the definition of where you are. Okay? Okay? This is a vector. And our real world is more complicated than xy. It is x, y, and z. Okay? So those are the difference between vector and scalar. So, you can give me some example about the scalar and the vector. Anyone? Scalar is maybe the answer is some value is a result from maybe x, y, or z. And the result is just a value of it. For this example, x, y, z, they are all the input for this example. Okay? So it will give you some value at different positions. But for this one, for the vector, for the x position, you will have a function. And this function is very similar to this one. The result of the x direction is according to the position of x, y, z. Okay? But the result of the direction y is also, the reason comes from x, y, z. So you can write down like, in here, you can write down, this is like, you call x, so you can say that like f of x, y, z, and x. Maybe you can write down like this way, maybe it's easier for you to understand. And for ay, you can write down like the function of the y is also related to x, y, z. And this one is f, z is also x, y, z. Okay? Those are different. To simplify the question, we all sometimes, most probably, because we want to make it easier to simplify the question, we try to calculate the equations in the linear world. What does the linear world mean? Can you tell me what does the linear world mean? Do you know linear world? Linear. Linearity or superposition. Have you ever heard that? Yeah. What is linear? Similar, but close. Linear. Have you ever heard of superposition? No? You? Linear. Line, like a line, right? Which means the result of the final total A is a summation of this plus this plus this. They are not influence each other. They can be independent. Okay? You can just put them, you can calculate this thing individually and then sum them together, sum up. Okay, this is a linear. To make the question easier. Okay? So, okay, one more example about the general form of our vector. This is what I try to tell you. So, there are three cases. If AY is 0, AZ is 0, AX is just 1. It's very easy, right? So this is this vector. You can see this is the direction of the unit X, unit Y, and the unit Z. So all of the vectors on this space are 1 to the X direction, okay? Okay? I hope you can read this one because we will have a question later. So you need to understand this is the total vector equals to x hat, unit vector of x. Okay? And then if A equals to y, all the vector goes to the magnitude, how big it is 1. Okay, everywhere is one direction to y. Okay? I take it slow, but you should understand because we are getting more and more difficult. And this is z. And color, different color means how big it is, the size. Okay? Okay? So, this is A total vector equals to x times x hat. Which means the magnitude, do you know magnitude? Magnitude, do you know magnitude? I talk about magnitude. Say loud in Chinese. Magnitude. No, magnitude. Do you know magnitude? You don't know Chinese. I want them to know. This is the word I repeat and repeat. Do you know anyone know magnitude? What is magnitude? No? 大小. I said how big it is. Magnitude. Okay? Magnitude it is important. So that's why I tell you. If you guys don't say it, you don't know what I'm talking about. Magnitude of this vector is changing according what? The position of x, but not changing according y and z. These three boxes are the same box. I just try to look at it in different way. I look at this box in this way, and I look at that from I think this is from the y direction. So they are the same, okay? If I look at this in this direction, you will see that the color of these arrows are changing according to different x. The color means different magnitude. If 0, there is no vector. If getting larger and larger s, the color is getting to this one. This is bigger and small. Okay? So this goes, you look at that this way. And for x and y, if you look at this box from the top, you will see they are the same because it is only changing according to different x. Okay? And this is another example. Our E-field is more complicated than this example, but I need to give you easy one to get in more and to give you more and more information. Okay? So, very similar. If vector A equals to y times x hat. So the difference according to y in different position of y, they will change. If you change x, it's not changing, but you change y, it's different. This is actually a position and the result of the vector. Okay? They are the same box. You look at that in different direction. And then z is very similar. Okay, nothing. So I put these examples together. You can see that those are the same box for x, y, x, and z, x hat. All of these examples have the unit vector to x. So all of them are going to positive x or negative x, positive x or negative x, all of them. But the magnitude of this vector is changing by different position. Okay? Still easy, right? So if you have a vector, this is what we are doing. We use the cross. And the magnitude you try to calculate is the magnitude of the vector A times the vector, the absolute value, the magnitude of vector B times sine theta. And the result goes to the direction perpendicular to A cross B. So, if there is a vector A cross vector B, the magnitude is this times sine theta of the theta between A and B, and the direction will become A cross B perpendicular outside the plane. Anyone know what is perpendicular? Perpendicular. Do you know perpendicular? No? What is perpendicular? Don't know perpendicular? 垂直啊。Okay? So direction will change. This is direction of vector A. This is direction of vector B. If you do the calculation, vector A cross vector B, the result is the direction of N. Okay? Where is N? N is the direction perpendicular to the AB plane outside here. You use your right hand to do the cross. You know perpendicular, right? It's like this way. And the direction here is like a 90 degree to this plane. 90 degree to this plane. This is perpendicular. Okay? So you never learn vector? No?
That's the basic.
Okay, then this is basic. Then let's review again. Okay. All right. Okay. So for this one, I just missed the hat here, so you can just put in. Okay, those are all vectors. This is only for vectors. Cross product. Cross product. Okay. So finally, we can discuss the vector differential operators. Those are gradient, can see your quiz, divergence, and curl. Okay? You can see that in the Maxwell equations. Right? You see curl and divergence here, but we will have some more there. What is gradient? If you have a scalar function f, the gradient is equals to f prime with respect to x. This function, partial derivative with respect to x times the unit vector x plus y and z. Okay? Then you can start answer the first question. Okay? And you need to sum them together. This is the first question. I want you to practice. You will notice something that it is a scalar, right? So when you use the gradient, what is the result? This one is a function, is a scalar, right? Times unit vector. Function times unit vector. Function times unit vector. So the result is what? The scalar function, you use the gradient. What is the result? Will become what? Scalar? You sure? Oh, right. Why is it scalar? This is scalar times vector plus scalar times vector plus scalar. Okay? So I give you a hint. You just write down ABCD on the data, on the answer paper, okay? On the answer table. And I will give you score later. Okay, this is the first equation. So, this is the first equation. I give you some minute to answer. Okay? Raise your hand if you need some more time. Okay? If you don't need time, then I will continue. Divergence. What is divergence? If you have the vector for the first scalar function for the direction x is ax, and it is for the y, and this is for z. Can see that? The result divergence will equal to x partial differential with respect to x plus other two terms, y and z. All again. So this is, so A is a vector, and the after divergence will become this. Okay? So you can answer your second question. I give you a hint. You have no reason to make mistake. For the second one, pick one. Pick A, B, C, D, E. Which one is the answer? Easy, right? Feel confident, right? Easy class. So far. You still doing? Okay, show me you are done for the second question. You finish the second one? No? No, okay. I give you some time. The second one. You need more time. Do you want to do a quiz? No? Just for fun, because you didn't take the class. Okay. Did you finish the second question? Yes? Second question? question? Okay. Give me a little time.
不要用白本啊。不要用到白本。哦，
真的很无聊，你们坐太久了。I'm so bored. You guys took too much time. I thought this is an easy question. Okay. Finish? Okay, then we can go to the next.
Anyone need couple minutes? Just raise your hand. Anyone? Okay. Sometimes you need the time to digest what I told you, but it's okay. It's common. Don't be shy. Just let me know. You are not clear. Okay. That's a good thing. You stop me and I slow down. It is a good thing because I believe that many students you also have the same problem. You just shine, just feel shy. Okay, so okay, you already have a question. For the third one, this one, we will stop here and you will take a break because this will take time. For the curl, you remember Maxwell equations, they have a curl, right? This is curl. How to operate the curl? Call this curl. Vector A. If A is a vector, you use a curl, you become also a vector. Okay, vector become vector. How to do this? See, you have the function AX, function AY, and the function AZ. They are all the scalar functions. Okay, you put AX, AY, and AZ here. Then you write down X hat, Y hat, Z hat here. You put the partial operator here. Then the result will become, you look at that. This one, AZ, the function AZ, partial differentiate with respect to y times ax times the unit vector of x plus this equation times these two elements plus these two times this equation times this element minus this 3, then minus this 3, you multiply this 3, then multiply this 3. You can see maybe you learned this before, right? Okay, another class. So the result will become the x direction unit vector times this one. You don't need to remember it. The only thing you need to do is just put this formation Just write down this formation and put them, multiply them together, and you will get this result. No one remember this result. You don't need to remember this result. You remember only this matrix. And you can get the result, okay? Anyone don't understand, raise your hand. It's very, no, you don't understand? Okay? A, B, C, X, Y, Z. Okay? Equals to A, B, Z. That is this 3 plus B, C, X. This is capital C. Okay? Plus A, Y, small c, minus C, V, X, minus B, A, Z, minus, which one? We have two. This one. A, Y, C. Okay? And the difference is you change this one to X, Y, Z, partial X, partial Y, partial Z. And this is AX, AY, AZ. You put the question here. Those are operators. And you make a partial differential equations, then you can get a result. Anyone still don't understand? Raise your hand again. Should feel okay? You know how to do it? Okay. Then you will have an answer for the question 3. So you don't need to remember anything. Those are just simple form. Then you will answer the question. Okay. For the number 3, the question number 3, you can do that. Just be careful. It's very easy to make mistake. Those are easy, right? Those are easy. Easy calculus, differential calculus. Okay. Then the question for number 3. So you now understand Maxwell equations, right? A little bit. Because you know the gradient, you know the divergence, you know the curve. That is what happened on Maxwell's equations. Let's take a little break and maybe we can start earlier because you need a little time to finish the third equation, the third question. Okay. So let's take a break. I hope we can come back earlier. Okay. Take a break.